translating integration into summation and taking that summation to infinity. That's infinite rectangles. What? How do you sum infinite things? Okay, so when you do a problem like this, all you really pretty much need is the A and the delta X. I know that because I'm thinking about the template that we talked about in class. And remember, this is the height times the base. Okay, the function gives you the height. The delta X gives you the base of our rectangles. And then, as you can see, all we need is the A and the delta X to be able to get our answer here. And we'll also plug in the F later. So we know this guy is the A, the lower limit. The lower limit is always at the bottom of an integral sign. And so I'm going to put 0 right there. And for our delta X, we need to know what the A and the B are, or are. Because that's our lower and our upper bound, and that'll give us our integral or our interval. Wow, I'm having trouble with my words. We know the top number on our integral sign is the B, and so we're going to go B minus A divided by N. That's the number of rectangles, and we're always going to actually leave this as N because what we're doing here is we're taking N to infinity. Okay, that's the number of rectangles, infinite rectangles. And then what we get after we plug in some numbers, we get pi minus 0 divided by n. A little bit of simplification will give us pi over n. And then we just plug our stuff in. So when I plug our stuff in, this is what we got. And then let's not forget, oh, and by the way, the I is always going to equal 1 and the n is always going to equal n, okay, for these types of problems. Most of the time, that'll be 1. It doesn't really matter since we're taking it to infinity if this is 1 or 0, but anyways, F equals sine, and so we plug the sine into it, into our sigma notation, and then we get our answer. This is our answer. It matches B in this case. The I ends up going up there with the pi because they multiplied it out, but it's the same thing.